So this series of videos will look at designing and building a solo winter camping tent. And in this first episode, I'm going to look at the design exercise. Now, in the beginning, most winter camping tents looked like this. Basic wall tent design, maybe in an 8x10 size, which was suitable for 3, possibly 4 people, very large for 2, and definitely not a solo tent. Decades later, the snow trekker design of freestanding tents came on the market in a similar nominal size here, maybe 8x10, is now a good 2-person tent, but still a little on the large side for a solo tent. And more recently still have come an absolute flood of cheap nylon tents on Amazon purporting to be winter camping tents. Many priced between $200 and $300, which does not inspire a whole lot of confidence in terms of build quality and reliability. So then last year I took matters into my own hands and converted a summer camping tent into a winter tent by cutting out the floor and installing a stove jack. And the result looked like this. So at last, for this year, I thought the exercise of designing and building my own solo winter camping tent might be an idea. And in this first video, I'm going to go through the design exercise such as it was. So what I've got here is most of a spare set of poles from a snow trekker tent. There's 4 6-foot 72-inch poles. All that's missing is the ridge pole. And when I ordered my snow trekker, it came with the wrong pole set. So Dwayne sent a replacement pole set and didn't ask for the originals back again. That's the kind of service you get from snow trekker. It's great. So anyway, I had these spare poles, everything but the ridge pole. These are the 4 leg poles from a smaller tent, essentially. So they're only 72 inches long. And the thought is maybe I can use these poles to make a prototype solo camping tent that will be smaller than an 8x10 snow trekker short wall. And so basically this pole here is the largest Easton pole you can get. So it's 3/4 inch, just under 3/4 inch diameter. That's about 745 outer diameter. And the inner diameter is 680 something. And they're nominally 2 feet long. I want to use these poles, but I don't just want to have a straight A-frame as the snow trekker is currently designed. I want the legs of my tent to form an angle, like a 150-degree angle, or a curve, in other words. If I could get bendable poles, it would implement a smooth curve, but these are the poles I have, so they're going to be 2 straight segments with a 150-degree angle. Easton sells 150-degree angles for their pole sets up to 1/2 inch. This is the oversized pole, 3/4. There are no angles from Easton. So I'm going to have to make my own. And the numbers I'm working with are about 680 thousandths of an inch inside diameter of the main tube here. And that there is a very good match to a 1/2 inch copper pipe, which has an outer diameter of 5/8 or 625. And then I can assemble the A-frame of a prototype solo tent, which would be smaller than an 8x10 short wall. And for the ridge pole, as I said, I've got 4 tube sets here for 4 legs. I will reuse the ridge pole from the 8x10 short wall. I just have to design my tent to have an exactly equal ridgepole length, and it's 75 inches for the Snow Trekker short wall. So what I'm showing here is a sketch by which I figured out the layout for the new tent design. As a reference, I've got the sizes for the Big Agnes Doghouse 4, my current tent, and the Snow Trekker 8x10 short wall, which I was previously using. So they're shown in dotted red lines. That is the Doghouse 4, and that one there is the Snow Trekker 8x10. My design is in the thicker black line. So in this plan view, it's a trapezoid rather than a rectangle. And over here in the profile view, the Snow Trekker is shown there, the Doghouse 4 is shown there, and my tent is also kind of a rhombus or something here. And basically it has the ridge height equal to the Snow Trekker at the door, but much lower at the stove end of the tent. The overall length, 92 inches, is the same as the Doghouse 4, and the ridge length, 76 inches, is the same as the Snow Trekker, which means the entranceway of this tent will be very similar to a Snow Trekker, and I can even use the same ridgeline pole, 76 inches, on both tents. But in other aspects, compared to either the Doghouse or the Snow Trekker, the new design is narrower in the plan view, 54 inches wide, and lower, shorter, in the profile view. It's about 3.5 feet high at this end. So as a solo tent, it squishes the space out of the stove part of the tent and puts most of the space where I'm sitting. So here you can see the chair and where my feet would go, a bin for gear and food, the box that holds the stove becomes a table. And a key element of the design that I wanted to achieve here was the linear length from the back of the tent through the chair where I'm sitting, through the stove to the other end of the tent. In the Doghouse 4, my current tent, these things are aligned vertically from one side of the rectangle to the opposite side of the rectangle, and that is a 92-inch length. And I know now from experience in that prototype, 92 works, it's a little tight. By changing the design so that the alignment from back of the tent through the chair through the stove is now at sort of an angle, crossing the footprint like this, I've got 109 inches worth of space there. It'll spread things out a bit, make things a little more comfortable, keep the stove a little farther from the walls of the tent, and just everything's better about that arrangement. Now, this setup shows the interior as it would be for the evening, cooking dinner, whatever, breakfast, having breakfast, but not for the sleeping layout. So as a solo tent, for the sleeping layout, the idea is you take the food and gear bin, put it outside, put the chair outside, maybe move this little table, and then this is what you'd have. Here's a 7-foot long rectangle which indicates my sleeping pad. Fits into the tent like this, and this little table thing could move and still be convenient for use in the middle of the night, just holding lamps and other gear. So this is how I started the layout. I got it worked out in the 3 orthogonal planes, but in order to figure out the actual panel sizes for the different surfaces, the faces of the tent, it would be too hard to calculate those just based on these sketches in the orthogonal planes, these projections. So for that, I needed to create a parallel sketch of this thing in a 3D drawing program. So here I'm showing a similar diagram of this tent in the SketchUp program, and I've just sort of set out the basic shape of it and used that then to generate all the dimensions I would need, the measurements I would need to size the different panels on the tent. So again, it's it's basically an A-frame triangle tent, except one end of it is much higher than the other, and one end of it is wider than the other. The next thing to mention here is that I had a little trouble while learning this from scratch on how to draw the slightly angled sides that I wanted. So I didn't end up drawing those as faces in this 3D SketchUp. Those are simply lines. And this is the face there. That is just a line as I've drawn it. But I can still use that line to get the overall dimension of what the face would be if it was pulled out and over this point here. And I have a similar one of those little lines implementing that angle there right here. So that's nominally a 145 or 150 degree angle, and again, the idea of doing that as opposed to just having a straight A-frame, which is what the snow tracker is to push out the interior volume a little bit and to battle the tendency of this large face here to sag inwards without the help of guy lines or battens. So what you can now see here is all of the various dimension lines I drew to figure out the various panel sizes, and there's going to be 6 panels, so an entire side is one panel. Then there would be 2 triangular or slightly modified polygonal end panels there, which can be sewed together. And then also at this end, the same thing, 2 of these panels. In fact, the true shape of the panel would be a 4-sided polygon implementing this angle here, but there will be 2 of them, one on that side and one on this side, and then they'd be not sewn together at this end. This would be a zipper to allow for a door. And with all these different dimension lines, recording the numbers from that, I can then transfer that information back to the 2D drawing program and lay out the panels on the available bolts of fabric that I can order. So here we have a product on Etsy, white nylon ripstop fabric, pure finish, 62-inch bolt at the bargain price of $3 a yard. The pure finish is what I was looking for. There's no coating on either face, so I don't need any waterproof coating. As for fire retardant, I can do that myself. I can add it later. But the main thing is I absolutely don't want the waterproofing. So here we see the final layout on the fabric that I have. 62-inch bolt is shown here as approximately a 5-foot width. And I've put 2 of them together with 1-inch overlap seam, and 180 inches is 5 yards. And on that larger rectangle, I can lay out 2 of the side panels, which is now this oblong trapezoid where each edge of the 4 edges has been figured out from the 3D SketchUp diagram. So the 76 inches is that ridge line, and this is one angle of the A at the door end, allowing for this slightly quadrilateral shape here. So that's like 45, 45 is about 90. And so this is one of the panels for the door end, 72-inch ridge height, 48-inch width with the quadrilateral. And then at the stove end of the tent, it's about 3.5 feet high, 27 inches wide, but still that quadrilateral, that same extra angle there, which as I mentioned was to push out that eave of the tent a little bit and help counteract it from sagging inwards. Now, it may still need a guy line to pull it out, or it might not. Only when the prototype is assembled will I really know for sure, and if I need the guy line or a batten, I can implement that later. So taking these shapes, two of these, and two of these, I can lay them out and mostly efficiently use the 10 yards of the 62-inch bolt. I've got here some older tubing, which is possibly polybutylene, or maybe it's an old kind of PVC. I don't really know. It's not sold in the store anymore, but it just happens to be the exact 5/8 diameter that I need, and it's quite rigid. So if it's a thermoplastic, I can heat it and bend it to make my 150-degree angle out of this. So we're going to go ahead and give that a shot with the heat gun here. All right, and we'll just let that cool for a minute. I can pull it out of the clamp. Pretty good. And with the tubes, it would be like this. And you know, there's it's very narrow in the middle here, and the tubes would kind of bump each other like this. So what I think I'm going to do is wrap a little tape around the middle part there to just provide a surface for those tubes to bump up against. Okay, so there's kind of a surface there that these tubes could then sort of hit and provide a bit of support to the end of the tubes. They don't bang into each other or otherwise bungle the situation. So that's one way to make a 150-degree angle for these Easton tubes. Okay, I've got here 18 inches of half-inch copper pipe, and I'm going to try to bend this by hand using one of these pipe bending springs, and see if I can get the same result as one of these things. So, a little padding for my knee here. Okay, let's see. Pretty hard to bend. Okay. It's going to be a little too hard to bend on my leg. I'll have to get a jig or something to bend it on. Alright, so here's kind of a knee pad, and if I put this ABS tube underneath it, I might be able to bend it across that surface there. See if that works a little any better. I got the bend started here, so I want to keep going in the right direction.
It's a little hard to see, but that's it right there, I think. Starting to go. Almost there. I'm getting wrinkles though, which means I'm not making a good bend. This wouldn't be any good for plumbing, but so it goes. Try to spread the bend out a bit more if I can get that. Oh, darn. That went too far. I buckled it. Okay. I buckled it. No good for plumbing, but it's not actually broken, so it might suffice. Okay, so I had to use an 18-inch piece to get enough torque to bend it at all, but it doesn't need to be nearly that long, so I'm gonna just take off the excess here and a little pipe cutter. Okay, and do the other side here. Got it trimmed down to size, and that's the angle there. I should do a passably good job of it. Might not have got the full angle on that one. Came up a little short. So I got one more piece of copper, so let's try that. Okay, this one's bending better. Looks like I'm not going to kink this one. That's probably okay right there. Kinked it again, not as badly. There's a real art to that. So I got 5 elbows. I need 4 for the legs, and I've got 1 as a spare in case I lose one. Or who knows, it might even break. Okay, so I need to make 3-way T's to attach 2 legs into a ridge pole. And the ones that came with the snow tracker could be used, but they're at the wrong angles. I have new angles now with the new design. So I'm going to try to make a 3-way T using the copper fittings. Now I know from the sketch in 3D that I need approximately a 90-degree angle on the 2 legs, and then the angle onto the ridge pole differs from one end to the other, but say for the door end it's like 120 degrees. So I can get a couple legs in here like this, and then so depending on how I solder this, I can get the approximately 120 degree angle going onto the ridge pole, and these are 45 degree elbows, so I get a 90 degree for the 2 legs. Okay, so I need the 2 angles are about 130 degrees and 75 degrees. So for the 130, 180 minus 130 is 50, so using the phone as the protractor here, I need about a 50 degree angle.
So I got the unleaded solder here. As a kind of an amateur plumber, I've found the leaded solder easier to work with. But hey, safety is safety. We got to observe the best practices. So all the joints seem to go well except the first one there, which I probably didn't heat quite enough. That one there might not be good. The rest of them look pretty good. Haven't done a solder joint in over 5 years. We'll just let it cool off for a minute and then see how it shapes up. Yeah, on this side, my solder drips are just huge. I put way too much solder in there. And I actually tried to melt that one and wipe it off, but failed. So, you know, from a plumbing point of view, they're lousy joints. But from this arts and crafts perspective, I think they'll do. So that would go on like that. And then we get a couple more here. So the assembly would look like this. Maybe I can turn this around a little bit. Yeah, so there you have the three-way assembly. So we'll just do another one here for the other end of the tent. Those are not great joints. They're slightly better than the first one. But I've done better, much better in the past. Seems pretty good. So that completes the design exercise. And now might be the time to note that this little image here shows DALL-E's best effort at my design concept. Specifically, the issue I had was DALL-E simply could not, would not, render a tent with a sloping ridgeline. So this is how I prompted DALL-E to produce the image of the tent. And this was the response from DALL-E. Unfortunately for me, I didn't get a chance to let ChatGPT know if this works, because DALL-E had just cut me off after 2 follow-up prompts, both of them hammering on the concept of a sloping ridgeline, which DALL-E simply would not produce.